Let's take a look at using Dynamics 365 Field Service to resolve equipment issues detected by IoT connected sensors. Here is a remote monitoring dashboard for a heating and cooling unit. The heating and cooling unit has two IoT sensors on it measuring humidity and temperature. Below we see that every few seconds, the sensor readings are sent via Wi-Fi to Azure IoT Hub or your organization's specific IoT provider, where they are stored and analyzed. If the temperature exceeds 70 degrees Fahrenheit, this is considered an anomaly, and an IoT alert is automatically created in Dynamics 365 Field Service. Here we see the temperature has spiked to 103 degrees Fahrenheit and is reflected in the IoT messages below. Let's take a look at the Field Service web app. In Field Service, go to IoT Alerts from the main menu. We see an IoT alert has been created for the spiked temperature on the HVAC unit. Basic details like date and time, IoT device, and the associated customer asset are filled out. Down below, the actual JSON payload coming in from IoT Hub is shown. Because the high temperature is an anomaly, we need to take action. But since it is an anomaly and not an emergency, we will first begin by creating a case to investigate the situation. Using the recommended business process flow, we will quickly create a case and enter relevant details. For incident type, we will choose power fluctuation based on past experiences, and this incident type can be recommended by AI machine learning models analyzing historical information. Once the case is created, a customer service rep will investigate remote solutions for the issue, like sending remote commands over the internet to reboot the device, or sending the customer troubleshooting tips. If the issue cannot be resolved remotely, the case is then converted into a work order to send a technician to the location of the heating unit. We will quickly create a work order and add a few more details, like work order type, in this case, an inspection. The work order is created, and all the details from the case and the original IoT alert are passed through. Information like account, incident type, customer asset, and IoT alert. Also, based on the power fluctuation incident type, recommended service tasks and an HVAC inspection are added to the work order automatically. The location of the customer is seen on the map as well. In the support contact field, we will note an expert who will be available for the technician to video call in case he or she needs help. After adding a few more work order details, we will head to the schedule board to assign this work order to a technician. We will find the work order in the list of unscheduled work orders and drag it to an available technician. Dynamics 365 Field Service can also automatically schedule the work order to the closest and best technician, creating a system where work orders are automatically created by IoT sensors and scheduled without any human intervention if desired by your business. After the work order is scheduled, the technician will see it on the calendar of his or her mobile app. The technician will see the location of the customer on a map and even the specific location where this work order will take place. In this example, building a roof. Tapping into the building a roof, the technician will see a full functional location tree of the customer's location and can see where various assets sit. The technician can further tap into the heating asset from the tree to see even more details. In the device reading section, live IoT sensor readings are displayed on a chart. Here we can see there is a clear upward trend in humidity and temperature. The technician can use this information for better context and troubleshooting. Back on the work order, the technician will begin the inspection process. The inspection form guides the technician through various questions and procedures. He or she will start out with basic information like name and date and time of the service. From there, he or she can move on to more specific inspection topics related to the specific issue on the specific asset. In this case, performing maintenance, checking condenser coil, and checking coolant level. If needed, the technician can take pictures as part of this inspection. After finishing the inspection, the technician will mark it as complete. If the technician is unsure of how to fix the issue, he or she can trigger a remote assist call directly from the app for a mixed reality video call with an expert. This expert may be at another location or at an office. When he or she answers, they will see the technician's field of view, and they can give guided instructions with drawings and can even share diagrams and other knowledge articles. This is a great way to extend and share veteran knowledge. Back on the asset, there is one last thing the technician may want to do: update asset properties. This ensures the organization has an accurate log of the condition and details of the asset. This is great for enabling any technician to take over service if needed and to help better predict maintenance needs. From the asset, the technician will go to the Properties tab. Here they will see a list of current and previous asset properties like firmware version, last date of service, and number of cycles. These are completely configurable based on your business needs. The technician will update properties like if they installed a new firmware version. And they may update the cycle count of the machine. Notice that the system automatically tracks the difference from the last cycle count as the number underneath the current cycle count of 211. Lastly, the technician will collect a customer signature and mark the work order as complete. Back in the Field Service web app, the dispatcher will see the work order is completed based on the color of the booking. Clicking into the work order, the dispatcher will see the completed inspection and the answers entered by the technician. Inspection results can easily be organized and reported on.